Now we're going to start talking about the mole. Obviously not the animal of a mole, we're going to be talking about a mole that we use frequently in chemistry class. Before we get to that, we're going to talk about dozens. I know this seems pretty elementary, but it's crucial, I think, to make sure you understand this before we move on to going to the mole. So hopefully you know that if you have 1 dozen pencils, that means you have 12 pencils. If you know that a dozen means 12, you should know that 2 dozen will mean 24. So you'd have 24 trees. Okay? Or that 0.5 dozen birds would be 6 birds. What I'm going to show you real quickly is something we've done at the beginning of the year called dimensional analysis. We know that 1 dozen is equal to 12. Okay. And then dozen and dozen will cancel out. Multiply across, 2 times 12 is 24 trees. Okay. Same here. 1 dozen is equal to 12. Dozen and dozen. 0.5 times 12 would be 6 birds. Now we could also say we have 96 cows, and if we want to know how many dozens of cows that is, we would go opposite. I know 12 would be in 1 dozen. So let's say 12 cows in 1 dozen cows. And cows and cows. Now we multiply across again. 96 times 1 is 96. Over 12 would be divided by 12. 96 divided by 12 would be 8 dozen cows. Okay, so simple conversions using dozens. So what we need to ask ourselves is, would we be able to count out 1 dozen table salt units? Now when referring to a unit of table salt, what we're talking about is the sodium cation and the chlorine anion. Okay. This ionic bond, this would be 1 unit of sodium chloride. So a lot of people try to count out 12 grains of salt, which is completely possible. However, what you have to recognize is atoms are so tiny, we can't see them with our naked eye. So there are billions and billions of NaCl units in 1 little grain of table salt. So 1 dozen is too small of a number to count out units of table salt or atoms of anything or molecules of anything. We have to use a much larger number. And the number that we use is called Avogadro's number, also referred to as the mole. This number is equal to 6.02 times 10 to the 23rd. This number is written in scientific notation just to make it easier to write and work with. If we were to write it out, it would be 602 This is 6.02 times 10 to the 23rd written out. This is a massive number. When we start working with numbers of this size, we're able to start talking about atoms and molecules and such. Just to kind of put it in perspective, right here is 1,000, here is 1,000,000, billion, trillion, and we're still a bunch of times larger than that. Okay? This number is huge. But at the same time, kind of like when we say a dozen is 12, a mole refers to this number. So we could use the analogy. A mole is like a dozen because So we could say a mole is like a dozen because a dozen represents the quantity 12, and a mole represents the quantity 6.02 times 10 to the 23rd. In chemistry, we use different particles, different representative particles, depending if we're talking about elements or compounds. Okay. And just like when we have a dozen trees, we have 12 trees. Trees would be the unit. When we're talking about these representative particles, we have different units for each one. So for example, if I have an element, I say atoms. So I would have whatever number of atoms for that specific element. Okay. If we have an ionic compound, we use the term formula units or just units. So I'd say I'd have X amount of units of sodium chloride. If I have a covalent compound, I would say molecules. I have X amount of water molecules. For example, if we had 1 mole of carbon, we would have 6.02 times 10 to the 23rd. And since carbon is an element by itself, we would say atoms of carbon. So if I have 1 mole of carbon, I have 6.02 times 10 to the 23rd atoms of carbon. If I have 1 mole of table salt, I have 6.02 times 10 to the 23rd formula units of table salt, or sodium chloride, or NaCl, all the same thing. Okay? So if we have 1 mole of each, the quantity is still the same. We have atoms of carbon, formula units of NaCl, and then water, because water is a covalent compound, we would say molecules. It's still 1 mole, so it's still 6.02 times 10 to the 23rd. Just now we say molecules of water. If we were to do some conversions between moles and particles, we would use the dimensional analysis method. If we have 2 moles of sulfur, we start with our T-chart. What you're given always goes in the top left corner, so we have 2 moles. And MOL is the abbreviation for mole, like G is the abbreviation for gram, and then of sulfur, so I'll just put the large S. Now, if I have moles here, that means I have to have moles down here. And I'm looking for atoms, because sulfur is an element by itself. Okay, so now what I have to think of, okay, what's my ratio between atoms and moles? So you have to remember 1 mole of anything is going to be 6.02 times 10 to the 23rd of that thing. So on top, with atoms, we'll have 6.02 times 10 to the 23rd. Atoms is going to be equal to 1 mole. Multiply across, 2 times 6.02 times 10 to the 23rd will give you 1.204 times 10 to the 24th atoms of sulfur. If we go backwards, I have atoms and I look for moles. Again, start with your T-chart. Always start with what you're given. 3.4 times 10 to the 21st atoms. Always write your units so that you make sure that you put your conversion factor in correctly. If I have atoms here, I need to have atoms down here so that the atoms can properly cancel out. And we're looking for mole. Again, our conversion between moles and atoms, 1 mole of anything is going to be 6.02 times 10 to the 23rd. So 1 mole is going to be 6.02 times 10 to the 23rd. Except this time what we do is we multiply across. 3.4 times 10 to the 21st times 1 is 3.4 times 10 to the 21st over 6.02 times 10 to the 23rd. When you divide, you'll get 0.0056. Since atoms canceled out, what we were left with was moles. And one thing, just to double check your answers, to see if they make sense, I know I need to have this number of atoms to make 1 mole. 3.4 times 10 to the 21st power is not even close to 6.02 times 10 to the 23rd power, so I'm not even going to be close to having 1 mole.